Last time in lesson 69, we learned about something called direct variation and how x varies directly with y. In today's lesson, we're going to continue using that concept, y equals kx, and the constant of proportionality, how x is an independent input, then depending on k, y comes out as a dependent output. We're going to solve problems like, if it lets me, these. First, the amount Ellen charges for banquet food varies directly as the number of people that attend. So y varies directly with x. Let's remind ourselves of this equation for direct variation. These are our clue words. Y varies directly with x. Gets divided by a constant. Ellen charges $7.80 for 60 people. Okay, so before we decide how much that would be then for 100 people, we need to know what this is. Okay, we know how many people and we know what it costs, but we don't know how much he's charging per person until we do a little dividing here. We need to know what k is, so we're going to divide both sides by 60. Okay, 78 divided by 6 is 13. So she's charging $13 a person for k. Now we're not done. It asks, if that's the case, how much does she charge for 100 people? 13 for 100, $13 per person at 100 people. That'll end up being $1,300. And we've done problems like this without thinking of it as varying directly before. Just like when we talked about the perimeter of a square problems last time, we've done perimeter of a square problems. We just never knew that meant that they were varying directly with a constant of proportionality. But, I mean, with proportions, right, basically it's 60 people means 780. So 100 people means, right, so you would just solve like we used to do those. You'd get the same answer. Okay, this is constant of proportionality is 13. 13. Driving at a constant speed, the distance Maggie travels varies directly with. That means if the distance varies directly, distance is y. K is always k. The amount of time she drives. Okay? If she drives 75 miles for distance in 1.5 hours, how long would it be for 100 miles? So we need to know k. We need to know what this multiplier is. So we divide by x. Because remember, we said that another way to rearrange these problems, if you're solving for k, is y over x is k. So basically that's what we're always doing. Okay, 75 divided by 1.5 is 50. K is 50. Now, two-step problem. So this is 50. You take that to solve for 100 miles. Well, then t is 2, right? 2 hours. How about if there's 23 people in line in front of Delia waiting to be helped, and 3 minutes later there's 18 left, how much longer Delia will have to wait to be helped? 18 was the output. That's where she ended up. That's the new number. I'm guessing we're following this pattern. We're going to use direct variation to predict. 23 was the input. Something changed. and then 18 was the output. Something was 3 minutes. I'm thinking if we try 18 and then after every 3 minutes, you basically lose 5 people. How much longer will she wait to be helped? Basically meaning how long until there's 0 people in line? Let's see here. Maybe we shouldn't use the 3. Maybe we should just do 18 or 23. I'm wondering if it's 23 divided by 18 is our constant. Let's see what they did for this. It's an interesting problem. Glad we did it. We can find the average length of time it took to help each person. Okay, so every 3 minutes they get 5 people helped. So they say the constant is 3 divided by 5, or about 0.6 minutes. I knew it was going to be less than 1, because 18 divided by 23, basically. So I think that's what we just did, is 18 divided by 23 is probably 0.6. No, it's different. But for every 3 minutes, they help 5 people. So they decide 0.6 times we need to get 18 people done. 0.6 is your constant. Times 18 people is, magic of television, 11, about 11 minutes. So sort of a direct variation problem. Just keep that one in your back pocket. If they have any problems like that, you can use exercise 3 on page 473. So sort of like in example 3 where we've got, for every 3 minutes they have 5 people. Let's just put time on top of miles here. 15 minutes for 3 miles. $15 minutes means 3 miles. So our constant is 5. So let's do 5 times 5 miles is 25.